Welcome to the standard form to vertex form lesson today. So what we're going to be doing is we're going to be converting something that's in standard form to something that's in vertex form today. So just as a reminder here, this is what the general forms look like. Here's the one in standard form. So we had ax squared plus bx plus c. Okay, and then we want to change it over to the vertex form, which has this form here. Okay, so we go from something that has no brackets, a couple x's in it, and then we go to something that has just the one x, with brackets squared and so forth, okay? So again, the key here is we need to find this part here. We need to convert this standard form into this perfect square trinomial portion here in order to get to the vertex form. Okay, so the way we're going to go forward with this is we're going to use area model to help us. So again, just a reminder, you're supposed to go through here, look at so you have to factor these, okay? So this is a good warm-up to, we need to factor these, so we always put the first term here, and we always put the third term here. Okay, and again, we are just dealing with perfect square trinomials today, so that when they go through, if I, square root this one, and if I square root this one, if I square root this one, see how that's perfect square, this is a perfect square. So when I take 6x times 2, it makes 12. So we know it's perfect square, right? So if I take this one, square root it, square root, and then I take these and multiply by 2, I get 4x. So yeah, this is a perfect square. And we'll check this one as well, 5 and x. So if I take those multiplied by 2, I'll get 10. Okay, so we know we're dealing with perfect squares. So all we have to do here is take the first one, take the third one, and then we know some number times some number makes 12. The same two numbers make 36. So again, the same two numbers have to add to make 12. The same two numbers have to multiply to make 36. So a quick way to find that is what times what. So 36, if you just square root it, it's 6. So 6 times 6 makes 36. 6 plus 6 makes 12. So in these other two corners, you have 6 and 6 like that. So if you factor these out, so this way here you get 6, and then just that, and then here we have an x. This way you have an x, and this way when you factor, you can divide out of 6, okay? So then you get x plus 6 is your two factors, and then you write it all squared like that, okay? Just simplify it up. All right, so let's do the same thing over here in the next one. Okay, so write the first one in this corner, okay? So that's the a goes in this corner here, and the c goes in this corner here, okay? So remember, it's like a is in here, c is in this corner here, okay? All right, and the other two we got to figure out, okay, what two numbers add to make 4, what two numbers multiply to make 4 that are the same? Well, 2 plus 2, 2 times 2. Okay, and then factor these out. X there, 2 here, x here, and a 2 here. So x plus 2, perfect square, yep. And just write it simplified, x plus 2 squared. Okay, and we'll do one more here. It's the same thing, x squared goes here, 25 goes there. All right, so now we're trying to figure out what two numbers will add to make negative 10, so be careful here, but make positive 25 here, okay? So square root 25, we get 5, okay, but 5 plus 5 won't make 10, but negative 5 and x, and negative 5x will make negative 10 here, okay? And then, yeah, so then we go from there, and then we can factor these out. So again, here, this is a negative 5, so we'll divide out the negative 5. Here an x can come out, here an x can come out, and here a negative 5. So then we get negative x minus 5 times x minus 5, and x minus 5 all squared. Okay, so these are all the perfect square trinomials, and that was a review of how to factor using the area model. Now that we've warmed up with factoring these trinomials, I want you to now do this activity where We have two parts of the trinomial. I want you to find the third term here to make it a perfect square. Okay, so again, a perfect square consists of the first one has to be a perfect square, so x squared. The third term has to be a perfect square, so like 4, 9, 16, 25, 36, 49. Those are all perfect squares, okay? So we want a perfect square here. And then the last condition is that these two, when you do square root them, so you get a 6 and an x, if you take 6x and multiply by 2, you'll get the middle term here, okay? So in the end, the number that you get in your factored form here, 6 plus 6 makes 12, 6 times 6 makes 36. Okay, so what we're going to do here is we'll write in, so we know this value here, we know x squared. So we're trying to think of, okay, so what two numbers here will add to make 2 that are the same? So 1 plus 1 will work. Okay, so you can just put in 1x like that. Okay, so then from there, we will go through and factor out what we can here. So here, this is x, right? So you know x, and then, so what times what would make x this way? So you could factor out an x here. So x times x makes x squared, okay? So we know this corner here now. But then right here, I know we don't know this one to factor out or divide out a number, but just think if we were trying to get 1x here, x times what would make 1x? Okay, so then you think, oh, it's 1. 1 times x would make 1x, right? Same with this corner here. X times what makes 1x? Oh, a 1. Okay, so once you get that, you can find the third term here. And that's 1 times 1 makes 1. Okay, so there's your third term. So you can write it as y equals x squared plus 2x plus 1. There's your third term to make it a perfect square. And then if you factor it out, it's x plus 1 and x plus 1 squared. Okay, so we'll keep going here. So again, we're using the area model in order to make the perfect square here. Okay, so we're trying to find the third term here to make it a perfect square. So again, we're going to write the x squared in because we know that. And then from there, the two other terms that go in the diagonal here, we're just going to take what two numbers add to make 4 that are the same. So just take 4 and divide by 2. So you get 2x and 2x like that. Okay, and then in order to determine the last one, we're just going to factor out the values here. So x comes out of here, x this way comes out of here, so that makes sense. X squared times x makes x squared. Okay, and then from here we have x times what would make 2x. So you know a 2 has to be here, and a 2 has to be here. So that last one in the box will have to be a 4. Okay, to make a perfect square. So then we're just going to write the 4 here to make it a perfect square, and then now we're going to write the factors. So it'll be x plus 2, but then we just write it simplified, x plus 2 all squared, like that. Okay? All right. So again, we're just warming up here in order to, if we can do this step, this is the hardest step. We can get this done. We can get to converting the standard form to the vertex form, but it just takes a little bit of practice finding that third term, okay? Okay, so we'll do this one as well, and I'll see if we can kind of shorten our steps here. So here, so we put the x squared here, that's the a term, and then take the b term and then, divide it by 2, right? So 3 and 3 will make 6. Okay, and then so when we did that over here, 1 and 1 would make 2, right? So just take the 1 and 1, and if you square it, you'll get this number. The 2 and 2, you square it, you get the 4. 3 and 3, you square it, you'll get the 9, okay? So that's just another way to do it, but if it just makes better sense to you go, okay, well, x squared here makes the x times x makes x squared. Okay, so then from there, what times x would make 3x? Oh, a 3 has to be here. What times x what times x will have to be 3x here? 3. Okay, and then you can find your last term, which is 9, because 3 times 3 makes 9, like that. Okay, so the third term goes right there. Okay, so this term goes right there, right? All right, so, and then from there, you can write the factored form. X plus 3 all squared, like that. Okay, so hopefully you're doing okay here with this. So now, can you handle it? See, these were all plus in the middle. So is it okay? Can you still handle it if it's a negative b value here? Okay, so again, x squared. Take the middle term here, divide by 2, so negative 4x, negative 4x. Okay, and then from there, figure out what goes along the side here. Okay, so you know x and x will make x squared. So what times x here? So what times x here will make negative 4x? So negative 4 will. Whoops, not the x, oh, sorry. And then this one's negative 4 as well. So once you know that, so then you're going to take negative 4 times negative 4. Your third term, to make it a perfect square, is 16. So this is now a perfect square trinomial, and you can factor it and make it look like this. Okay, so x minus 4. X minus 4 twice, so square it. Okay, here's another one. So divided by 2. Okay, you get to there. And then you are going to write the factors on the outside here. Okay, so negative 5 will make these. So negative 5 times negative 5 is positive 25. So that's your third term. Okay, and then this is what your perfect square will factor to look like this here. Okay, and here's the next one. So this gets a little tricky. We have negative 3. We need to divide it by 2, so we're just going to write it as a fraction. Like that. Okay, and then, so you know your factors here will be x and x, like that. So then, from there, we're trying to figure out, okay, so what number goes here to make it negative 3 over 2x. Okay, so you know you need a negative 3 over 2 here and a negative 3 over 2 here. And so then when you take the negative 3 over 2 times negative 3 over 2, makes positive 9 over 4. Okay, so your factored form will be x subtract 3 over 2 squared. Now that we've completed the warm-up of just kind of trying to build a perfect square trinomial and then get it factored, we are now ready to try to convert from the standard to the vertex form. Okay, so again, this method here is the area model method. So just take a look at it, keep an open mind, and then if you are not sure if you like this method, there is another video posted on just, you know, kind of doing it more of a formulaic way, a step-by-step, kind of do this, do this, do this, instead of using a box, okay? So check out that video as well. All right, so we have our first standard form here. So again, it's a simple trinomial. A is equal to 1. So what you're going to do is you're going to go through and what you did before with the warm-up. You're going to write the x squared. Okay, and then so from there, you are still going through the whole process of finding that third term. You have these two here. Okay, and then right now, just don't worry about the plus 2 right now, okay? So with these two here, can you find the third term that'll make this a perfect squared? So you take your middle term here and then divide it by 2, so you get 3x and 3x, like that, okay? And then if you saw the trick above, you know that this will become 9, but if not, just go through the steps of factoring out the values here. So you know x times x will make x squared. And then here, 3 times x will make 3x, and 3 times x will make 3x. So the last box there has to be 9 because 3 times 3 is 9. Okay, so we're going to write these outside of the box now. So I'm going to write the factors on the left side. So we have the x plus 3 and x plus 3 that came out, that were factored out. Okay, so these are those terms there. And then inside the box, we have x squared. Okay, remember, add these up. That's 6x and then plus 9. Okay, so what's happened here is that you've gone from taking this and finding a perfect square by finding this third term 9, okay? All right, but what's happened here is that now this equation looks like this. It has a 9 here now. So we need to, not make any changes here, and we need to adjust this new part that we added here, okay? So, how can we get this back to look like 2? So what you would need to do here is if I take 7 and subtract it, I will get 2. So I'm just trying to balance everything out and correct for the change that I made, okay? Because I now have a 9 here and it should be a 2. So if I take the 7 and subtract it, and I'm going to do it on the other side as well, then it will now become what we had in the original equation, which was x squared plus 6x plus 2. So I'm just trying to restore the balance here, and so that it becomes 2 again here. Okay, but then I added the 7 on this side too, because again, this x plus 3 plus x plus 3 times x plus 3, right, is actually this here. So I'm adding a 7 just to make sure it's the same on both sides. And then what happens here when I clean it up is I have the vertex form now. Okay, so here's the vertex form. Okay, so we went from taking the first two, using the area model to complete the square. Okay, so to find that third term, that's a perfect square. And then, so then we brought it out of the box. So we wrote the factors out here. We wrote what was in the box over here. But then we double checked with the original formula, and it was supposed to be plus 2. So it was x squared plus 6x plus 2. But now it's a plus 9, so I wanted to correct that and subtract 7 here to make it plus 2 again. So when I did that, I also wrote the negative 7 on this side. And then when we clean this up, look, you're in vertex form. So the standard form here is equal to this vertex form here. And I'm just going to write my final answer separately in just vertex form like that. Okay, so if you watch both videos, you'll notice that these are completely different ways, to go about finding the same thing. So it's kind of nice to see both perspectives. Okay, so that's why I give them both a chance, learn them both, so they can both be tools. Okay, all right. So let's go to the next one here. So we have an actual a value here. We have 2. So again, what I want you to do is I want you to divide that 2 out. Okay, so whatever number, if it's not a 1, if it's a negative 1, if it's a 2, a 3, a 5, whatever, take it out, divide it out, okay, and then rewrite it. So when we write it here, we will have okay, so we'll have that value there, and I'm just going to use a square bracket. Okay, so now that we have the a value factored out, what I want you to do is continue with the way you did right here when you had the simple trinomial. So you're going to just look at these 2 values here and get them to a perfect square. Okay, so we'll take the x squared, put it there, and we're going to think, okay, here's 8. What 2 numbers that are the same make 8? Add up to 8. Oh, so that's 4. Or you can just divide this b value by 2. Okay, so since it's positive 8, we need positive 4 and positive 4. Okay, so then from there, we need to figure out the third term here. So we're going to factor them out. So we have x and x will make x squared. X times what will make 4x? 4. So again, here, x times what? 4 will make 4x there. All right, so that will help us find our third term. 4 times 4 is 16, like that. Okay, so now we're going to take everything out of the box. Okay, so we're going to take everything out of the box, and then we're going to compare it with what we used to have. Okay, so we're looking at, remember, the trinomial here in the square brackets. Okay, we were trying to complete the square here. So we took the x squared and the 8, and we found the third term. There it is. But now when we go back to the original trinomial on the side of the square bracket, see how it was supposed to be 15? But now we have 16, so we have to make our adjustment here. So if I subtract by 1, I'll get 15. All right, so then I need to do that on this side as well. So when we do that, you can think of, okay, so when we do that, so now we can write it like this, squared minus 1, like that, and then this becomes 8x plus 15. Okay, so now it looks just like what you have in the bracket here. Okay, so now we want to now place this piece back right in here. Okay, so 2 times x plus 4 squared minus 1. So now we've placed this into here, okay, because these are equal. And then we don't want those square brackets, so we're going to multiply this 2 in. And whenever we distribute a number in like that, it removes the brackets, okay, but you know, we're going to leave these brackets here. But it removes the square brackets. 2 times -1 is -2. And there is our new vertex form of the original standard form equation. Right there, okay, to here. So that was our first example, couple examples. I know if you feel a little bit intimidated or oh, I don't know if I can do this, just kind of look at some more examples, okay? And you'll find just with a bit more practice, it'll become more straightforward and so forth, okay? And again, I've left this till, you know, the end of the semester because it is one of the tougher things in Math 10. So that's why I just got to keep working through your way through it and just keep practicing them. And as you get more and more practice in, you'll get more confident. Okay. All right. So we're going to do some more examples here, and yeah, and then you know like where the a is 1, and then where the a is not equal to 1. And then hopefully after these 4 examples, you'll feel more confident and so forth, okay? And then you can go practice and then try the checkpoint. All right, so let's get to this one here. So again, we have a simple trinomial. A is equal to 1, so I don't need to divide any numbers out here. So what we're going to do is then we're going to make our table, our little area model square here. Okay, and we're going to put the x squared here. Okay, so again, we're just looking at that part there. Okay, so so the 8, if I divide by 2, I get 4. So I get there, and then hopefully you're getting to the point where you're like, oh, I could just you know, I just multiply these numbers and I get this one. Okay, so you can figure out it's 16, okay? But still go through the steps and factor out what you need here. So x, this is 4, that's 4, okay? So we're good. So then we're going to take it out of the box and write what we found from the area model out of the box. And we clean it up. So x squared, add these two, 8x. And then add the like terms up, right? And then 16, okay? So then we go back to the original and we're comparing here. Oh, this is 1 more than that. So I need to correct it so that it becomes 15 again. So you're just going to subtract 1 here and subtract 1 here. So when we do that, we can rewrite it and it'll go back. So this will become x plus 4 squared, subtract 1. And if we correct this side, it will go back to what it used to be. Okay, so now you found this is the same as this here. So here's your vertex form, right? Y equals. There you go. And there you've converted your standard form to your vertex form. Okay, and again, you have to have the y equals to get full marks. Okay, all right, and so then you have the x squared, x plus 4 squared minus 1. So you have it in the vertex form. Okay. All right, so let's try another one. Okay, it's the same thing. I don't have a number here. I just have a 1, so I don't need to divide anything out. Just going to go and build our area model here. Okay, so then you have x squared goes in this corner. These two, it's what this divides. If you divide this by 2, you get 2x, 2x, okay? And then you've seen the pattern here. You just take that and you square it, okay? And you get that number. But otherwise, you can kind of go through the steps here where you have to factor it out. So this and this will make x squared. X times what will make 2x? Well, 2. X times what will make 2x? 2. So then 2 times 2 is 4. Okay, and then you write your two factors out like that. And so that's the outside part, and then the inside of the box is right here. Okay, and then this is your correction step. How do I go from here to here? So see, that's 4. I have minus 3. So we need to get 4 back to negative 3. So we're trying to figure out what we can add or subtract here. So what I want you to do is go back to this example here. And this is what you do. So see how we had 16 and we had to get to 15. So all you have to do is take the number that you have to have. And I want you to subtract by the number that you need. Okay, so when you are, sorry, that you have. Okay, so the number that you need is here. And then subtract by the number that you ended up getting here. And when you do that, you get negative 1. And that's what you subtract on both sides or add on both sides, okay? So same thing here now. You have a negative 3 and you're tired. You're like, I don't know what number to add or subtract here. So then go negative 3 and you're going to subtract the 4 here. And then you end up with negative 7. So that's what you have to put here and there to balance it back out. So 4 subtract 7 is negative 3. So if we clean this one up, so we'll have x plus 2 squared subtract 7 is the same as x squared plus 4x subtract 3. Okay, and that's the original. So it's saying this standard form is this in vertex form. So let's rewrite it with the y equals. And there we go. We're in vertex form now. On to now the toughest ones that you can see. So again, if you kind of got what you're supposed to do here, these are not going to be too bad, okay? All right, so they're just tougher because there is a number here. So there's just an extra step in all of your work, okay? So the rule of thumb here is you're just going to take, you want it to be a 1 here. So you don't want this negative 3 here. So just take that negative 3 and divide it out. Okay, and then rewrite it. So that negative 3 is out here. Oops, negative 3. Okay, and then square brackets. X squared, that's positive 6x here. And then don't stress that this last one is a fraction. Just write it as a fraction. Just make sure all the signs are correct here, okay? Because we have, so we have negative, negative makes positive x squared. Negative, negative makes positive 6. Negative, negative makes positive 17 over 3. Okay? All right, so don't stress about this third term here. So what we're going to do from here is we're going to use the area model to complete the square here. Okay, so make our box. Okay, x squared goes here. Take the 6 divided by 2. A 3x goes there and a 3x goes there, and then you probably figured out, oh, the last one's got to be 9, okay? But otherwise, just, go through the steps here and factor it out and figure this out here, okay? So x times what makes 3? 3. Here, x times what makes 3? 3. So then 3 times 3 will make the 9 here, okay? And then you want to go through here. Okay, and equal, take everything out of the box here. Okay, so we've taken everything out of the box here now, and then I'm looking at this. Okay, it's a little bit messy here, yes. Okay, so again, just like we did up here, when we needed to get whatever number we got back to this number, we take this number and we subtract this new number, okay? So I know it's going to get messy here, but just just, yeah, it'd be okay. Just a little hard part here. So this is the number we need. And we're going to subtract by the number that we got here, okay? All right, so it's a little bit annoying, but just all you have to do is find a common denominator. Okay, so common denominator 3, so that makes this 27. So this cleans up and becomes negative 10 over 3, okay? So whatever number you get when you subtract them is what you subtract on both sides, okay? So let's go ahead and do that. So this is going to be negative 10 over 3, and this one's going to be negative 10 over 3, okay? All right, and then, so let's rewrite that. Okay, so then we get to there, and then we're going to put it back into the vertex, into this form up here. So since we've completed the square here, so we're going to write y equals, and then we have the negative 3 bracket, and then we're going to put this vertex form part here back in. Okay, but we still have the square bracket, so again, we're going to multiply this negative 3 in, and it'll take care of this fraction here. Okay, so when this 3 multiplies here, remember, it'll be like negative 3, and then 10, like so negative 3 times the negative 10 like that, so it cleans up to. Okay, it cleans up to 10 like that, okay? There's the vertex form. It's kind of a trickier one here. So I just want to go and do another one here which doesn't really have a fraction come out because it's already, tricky enough as it is to complete the square. So I just want to go find a nicer one here. So F, like we'll try F here. So this is an example of the hardest one, going like where you have to find the ones with fractions coming out. That's kind of more next year and so forth, okay? So let's just try this one here, and then that should be enough for this video. Okay, so again, you have an A term here, so it's negative 2, so let's get that negative 2 out of there. Okay, so then we write y equals negative 2 bracket, these two cancel out, x squared, that becomes positive 6x, and then that becomes negative 10 like that. Okay. All right, so from there you're going to use the area model. So you are going to build your box here. So again, you're looking at changing that and finding the perfect square trinomial that will work here. So we'll make our box here. Okay, we'll write our x squared there. Okay, take this number and divide by 2, so 3 and 3. Okay, and then the last one has to be those 2 squared, right? So from there, you're finding your factors here, dividing out. So 3 and 3. So then now you're going to take it out of the box here. Okay, and write the other side. Got the stuff that was inside the box in here. Write it here. Okay, so then you get to there. All right, so now you're comparing back with this trinomial that was here. So you still have the x squared, you still have the 6x, but now you have a 9 here. Okay, so let's figure out how do we kind of restore the balance here. So it used to be 10, and then it became 9, so we're going to subtract that, and we get negative 19. So that's what we're going to subtract here to get it back to negative 10. And do that on the other side. Okay, so this one is more of a typical question, the hardest question that you'll see this year. So there's no fractions coming out that you have to be stressed out about, okay? But again, we've been practicing fractions all year that I should be able to throw those at you. Okay, so there's that. That side's cleaned up. And then this side here, 9, subtract negative 19, or sorry, subtract 19 is negative 10, like that. Now we're back to here. So now this is the vertex form of that, but we need this here with the negative 2 here. So we're going to take this and put it back in here. So we're going to rewrite it. So negative 2 And then we'll write x plus 3 squared and subtract 19. Okay, so we're going to replace this with this, okay, because this is the same. All right, so, but we don't have two sets of brackets with our vertex form, so now we're going to multiply this negative 2 back in. And when we do that, we will get to our final vertex form that we needed. So, but just be careful, negative 2 goes here, but leave it in front. And then negative 2 times negative 19 is positive, sorry, negative makes positive 38, like that. Okay, and there is your vertex form after all that work. Okay, so again, hopefully if you've watched both videos, you'll find that maybe this method here is kind of nicer, just because you're going through if you've been working with the area model, you know how to use it really well, and then taking stuff out of the box and then making it match to where it used to be. Yeah, so it's you might find this method a little easier than the formula method, but again, it depends. Everyone's different, so you may prefer the formula method. Okay, but again, learn both. All right, so go practice lots of these, please, and then try the checkpoint.